In the third of a second after you tap a link, about a dozen machines on several continents each do one job in a fixed order, and any one of them failing shows you an error page. Your thumb touches a link. Watch closely. We are going to freeze time right here. Underneath that frozen screen, an errand has already left the building. About a dozen machines on several continents, each with one job, and if any one of them fails, you get an error page. Here is the puzzle to carry with you. Light inside a glass fiber needs 56 milliseconds just to cross the Atlantic and come back. And a page only feels instant if it lands inside a tenth of a second. So how does an errand across an ocean beat your own eyes? Once, every name on the network lived in one typed-up file, copied by hand to every machine on it. In November 1983, Paul Mokapetris replaced it with a tree of small offices and gave every answer a best before date. 9 years earlier, Vint, Cerf and Robert Kahn had made a stranger choice. Let the network be stupid. Let it lose things, jumble things, duplicate things. The two ends will count the pieces and repair the damage themselves. Back to your frozen thumb. Your browser has a name and no idea where that is. So it checks its own pocket first, then the operating system's. Most of the time the answer is already sitting there. When it is not, a helper called a resolver asks 3 questions, always in this order. Whohandles.com? Who handles this site? And finally, what is its number? That top office is one of only 13 names, answered by about 2,000 machines. The one you reach is almost certainly in your own country. Now your browser has a number and opens a conversation. Hello, I hear you too. That is one round trip, and sealing the line costs a second one. Across the Atlantic, nobody can buy their way under 56 milliseconds. Then the errand itself goes out, and it is astonishingly small. A few hundred bytes of plain text that a person could read. Send me this page. That is nearly the same one-line note Tim Berners-Lee was sending in 1990. The answer does not come back as a page. It comes back chopped into numbered pieces, 1,460 bytes each, thousands of them, taking different roads through a dozen junctions. So before I show you, what do you think happens when one of them goes missing? They arrive jumbled. Nobody in the middle noticed and nobody in the middle cares. Your own device restacks them by number, sees that 47 never came, and simply asks again. That is Cerf and Kahn's bargain, still working 50 years later. Now the reading begins, and it happens entirely on your own device. The page's text folds into a tree of boxes. The style sheet folds into a matching tree of looks. And until all of that style has arrived, your browser refuses to paint a single pixel. The two trees merge into a list of only the things that will actually be visible. Then the sizes and positions are worked out, the colors are filled in, and the layers are pressed onto the screen. You cannot color a box before you know how big it is. And then the browser discovers it is not finished. The page names 70 more files it needs, pictures, fonts, code. So everything you just watched starts again, dozens of times at once. Let us add it up honestly. For a copy of the page kept near you, a 25 millisecond hop away. The name was already remembered, so 5 milliseconds. 2 handshakes take us to 55. The first byte back lands at 100. The pieces arriving and the drawing carry it to 300. And notice, about half of that was nothing but light traveling. None of it was a computer thinking hard. Move that page 6,000 kilometers away and not one line of its code changes. The same tap now takes nearly twice as long. Every extra millisecond is geography, which is why companies physically ship copies of the page to cities near you. But be honest with yourself. 0.3 of a second is what the machinery can do, not what the web usually does. The typical phone page is 2.6 megabytes across 72 files. Only 62% of them get their main content on screen inside 2.5 seconds. Now load that same page again. Remember the puzzle. Light needs 56 milliseconds to cross that ocean and come back. This time, almost nothing crosses it. The name is still remembered. The line is still open. The files are already on your disk. It is not faster. Most of it simply never runs. 3 lines hold the whole thing together. A name is looked up, never stored. The network is allowed to lose your data, and the 2 ends count it back. And the fastest request in the world is the one nobody ever makes. Time starts again. Your thumb lifts and the page is simply there. Everything you just watched was logic. Names, numbers, sentences. But the piece that crossed the ocean was a real pulse of light in a real glass thread lying on a real seabed. That thread is where we go next. Thank you for watching. Our small team works tremendously hard on every one of these animations. Following, subscribing and sharing is what keeps Baucis alive. There is a new video every day. See you tomorrow.